Hello, welcome back to graphing quadratic graphs. This one we're talking about in standard form, and we're also talking about their properties. If you have been with me before with graphing quadratics, a lot of this information is very repetitive. So we have a quadratic function where y equals ax squared plus bx plus c. Y can be replaced with the function of x equals, and then the rest of it. That's how we've seen it before. The parent function is the function of x is y equals x squared. This is where the function begins. Okay. The parabola is the shape of a quadratic graph, and it's usually kind of a U shape. It opens up if the number is a positive. If it's a negative, it opens down. The axis of symmetry is the fold or the line that divides the parabola into two matching halves. And so a lot of times when you see it, you'll see it as a dotted line that goes through the vertex straight up and down. And so that would be your line of axis of symmetry. The formula, you can find the formula if you know what the negative of the opposite of b divided by 2 times a, you can find that axis of symmetry. It's also, if you can identify what x is in your vertex, it is your, it's also your line of axis of symmetry. Your vertex is the maximum or minimum point. It is also known as HK, where H is your X value and K is your Y value. When I take a look at maximum and minimum points, the vertex is the minimum point when the parabola opens up. It's maximum point when it's at the highest point of the parabola when it opens down. So it's just where the parabola changes directions, okay? The domain is for all quadratic functions, and in all cases, because there are arrows at both ends of the parabola, we know that it is continuing to widen as it gets larger and larger. So that stands to reason that the domain for every quadratic is all real numbers, or an infinite number. Range is for every quadratic function that starts at the vertex and is either increasing, going up, or decreasing, going down. And so y would be every number greater than this point right here, and y would be every number less than. It's also or equal to, because it can be that number and then down, or it can be that number and up. So we're going to label the vertex, the axis of symmetry, the maximum or minimum point, and the domain and range on these. And so again, remember, vertex is where it changes. So in this case, it'd be -2, -3. It has an upward open, so it has a minimum. The axis of symmetry is where the x is at -2. The domain is all real numbers or infinite number of solutions, and the range is starts at -3 and goes up. So y is greater than or equal to -3. Okay, take a look at the next one. This parabola opens down. The vertex is at 0, 3. It has a maximum because it opens down. The axis of symmetry in this case is where x is 0, or you could say the y-axis. The domain, again, is all real numbers or infinite answers. And the range would start at 3 and go down, so y is less than or equal to 3. Okay. We can take a look at these, and remember that it was a over x, or sorry, x minus h squared plus k. Just keep an eye and remember that h is the number here, k is the number here. This should be subtraction for it to be a positive. If it's plus, then this would be a negative answer. Okay? So our axes of symmetry in this case, I only have a times x squared. So if I spread that out, I would do minus 0 squared plus 0. So my it's at x is 0. It's at the parent, because this is a parent one. My vertex is at 0, 0. On this one, I have, it is, this would be negative 1. When I'm looking at B, I see that this is in standard form, where I have y equals ax squared plus bx plus c. So in this case, my a is negative 1 and my b is positive 4. And I can use that formula, remember the formula from here, where we have x is negative b over 2a. So if I use that negative b over 2a to equal x, in this case, my a is negative 1. Oops, sorry. My b, is 4. And my 2 times my a, which is negative 1, gives me negative 4 over negative 2, which is 2. So my x is going to be at 2. So my axis of symmetry is going to be at 2. And now I have to figure out what my vertex is. Well, I already know my x is 2. So if I want to know what my y is, then all I have to do to find out what y is, all I have to do is replace x with the 2, and that'll give me my y. So I have y equals negative x squared plus 4 times x. So 2 squared is 4, so that's negative 4. And 4 times 2 is 8. And negative 4 plus 8 is 4. So that means that my y is at 4. And so that's using this equation they gave us earlier to finding our x value, which allows us to find our vertex. If I take a look at the next one, I have y equals 3x squared plus 1. And so what I'm going to do is I need to find the x, so I know my axis of symmetry. So I'm going to do the same thing where I have, this is A and this is B. No, this is actually C. B, in this case, is going to be at 0, because if I rewrite this as 3x squared plus 0x plus 1, there's my A, my B, and my C. Okay? So I'm going to have my opposite of B over 2 times my A. And so that's 0 over 6. This does not work. I do not have 0 divided by 6 is going to be at 0. So if I put 0 back in, 0 squared is 0, plus, times 3 is 0, plus 1 is 1. So my vertex is going to be at 0, 1. And my last one, I have y equals 2x squared minus 8x plus 7. There's my A, there's my B, and there's my C. And so I'm going to have the opposite of B. So the opposite of negative 8 is positive 8. and 2 times a is 4. 8 divided by 4 is 2. So my axis of symmetry is at 2. And then if I put 2 back in for my equation, 2 times 2 squared minus 8 times 2 plus 7. That's 4. 4 times 2 is 8. 8 times 2 is 16. And bring down my 7. This is negative 8 plus 7, which is negative 1. So y equals negative 1. So this is at, the vertex is at 2, negative 1. So using this equation right here, we can figure out what we need for each of our x values. So if x is 0, plug it in, find out what y is going to be. In this case, it was 1. If x is 2, plug it in. We found that was negative 1. If you have any questions on these, please make sure you're checking in with your teacher. They may have a different way of teaching this to you. Translations are the movement of the parent, and A tells whether or not it is going to, if it's stretching or if it is compressed, so if it's narrow or wide or just the standard. It can also tell you if it is reflecting over the x-axis. If it's negative, it's going to be reflecting over the x-axis. Okay? So if you take a look at these, let's see if I can get this enlarged. So we have 3 functions. We have the parent, which is x squared. And so when you're looking at these, the x squared well, this is the opposite. This is the negative x squared. This one here, see if it's decimal. See how it's decimal? It's very, very wide. This is a parent one because it's the negative x squared, so it's the parent. And then see how this one, where a is greater than 0, see how it is quite a bit skinnier. The larger this number, the skinnier that this is going to be. Okay? So when I'm widest to narrowest, for widest, remember the widest, those are less than 1 but greater than 0. So this would be the same as 1.5. This one would be the same as 0.5. Oops, not a negative. This one is 2. This is negative 4. And this is 1. So this is what A's are. So if I'm looking for the widest, I want the one that is the between. Remember, if A is greater than 0 but less than 1, it's going to be positive, but it's going to be wide. It's going to be a decimal. So this one would be wide. This would be the next. Then this one, then 2, and then negative 4. Okay. Vertical translation, we have ax squared plus c. There's no b, which means that b is at 0. Okay. Because there is no b, when you take a look at this one, this is your parent. It has the vertex is at 0. This one, the vertex is at 0, 1. Okay. So, so it shifts up on the axis. It comes straight up. We're going to look at this one. This one's going to go up 6 from the parent. This one is going down 1. So this is your K. And that's your shift. So it's going to go down 1. This is your K. And it's going up 6. Steps for graphing a quadratic function. Axis of symmetry is x. So you can use this formula. Vertex is x and y. Once you find x, you can find y. You can have a table, 5 points minimum with a vertex in the middle. I usually start with -2 and work up to +2, but sometimes you have to start at a different place. So be aware that you may have more than 5 points, and then you want to figure out which one's going to be, because the one at station 3, that should be your vertex. Okay? Plot the points and then state the domain and range. Remember, domain is always going to be all real numbers or infinite, and the range is going to be where the maximum or minimum is, and going in the direction of the opening. So let's take a look at this one. I have y equals 1/2 x squared. And so I need to determine what the axis of symmetry is, the vertex, the domain and range, and then determine whether it has a minimum or maximum point. So when I take a look at this, I have y equals 1/2 x squared, where a is 1/2, h is 0, and k is 0. So my vertex is going to be at 0, 0. My axis of symmetry is also going to be at 0, so where x is 0. I need to come up with 5 points. So since I know that it is going to be the vertex at 0, 0, that's going to make it easier. So I have my x and my y, and I know we're going to have 0, 0. Because it's a fraction, I'm going to use, for x, I'm going to use multiples of 2. So I'm going to use -2, -4, 2, and 4. 4 squared is 16. Half of 16 is 8. 2 squared is 4. Half of 4 is 2. -2 squared is 4. Half of 4 is 2. -4 squared is 16. Half of 16 is 8. And so here's my ordered 5 points. Let's see, so if we do these by 2s, I should be able to make it fit. So at -4, -2, -4, +8, 2, 4, 6, 8. -2, 2, -2, up 2. 0, 0, 2, 2, and 4, 2. 2, 4, 2, 4, 6, 8. Okay. Don't forget your arrows on your parabola. What was the other thing it wanted to know? What the minimum point is. The minimum point is at 0. So it has a minimum, and the domain is infinite, all real numbers, and the range is y is greater than or equal to 0. Take a look at number 2. I have 3x squared minus 4. Doesn't give me much more information than that, so I can use that formula where x is the negative or opposite of b over 2 times a. And we know that a is 3, and b, in this case, there's no x, so it is 0. So if I have 0 over 2 times 3, I get 0, so x is 0. And if I plug 0 in for x, that's 0 minus 4 is -4. So my vertex, so my AOS is 0. My vertex is 0, -4. If I use negative 2, negative 1, 0, 1, and 2. Plug in. Negative 2 times negative 2 is 4. 4 times 3 is 12. 12 minus 4 is 8. Negative 1 times negative 1 is 1. 1 times 3 is 3. 3 minus 4 is negative 1. There's my 5 points. Graph it. I have negative 2, 8. I have negative 1, negative 1. 0, negative 4. Whoops, that would be here, because these are going by 2's. 1, negative 1. And 2, 8. So you'll notice this is a very skinny parabola that has a minimum. The domain is all real numbers, and the range is y is greater than or equal to negative 4. Okay, if you have any questions, check in with your teacher. Thank you.